Hello everyone, welcome to week 5 part 2. Introduction to iterators. Iterators are one of the three main components of the standard library: containers, iterators, and algorithms. So the three main components of the standard library are containers, iterators, and algorithms. So iterators is one of these three main components. Standard library containers are pre-packaged. They're sufficient for most applications. Using the standard library helps you reduce testing and debugging time. The standard library containers are data structures capable of storing objects in almost any data type, but they have some restrictions. So it's components that are already built for you, so you call these components and reuse them. They're pre-packaged already. Saves you time and effort. You don't have to reinvent the wheel. Iterators, which have properties similar to those of pointers, are used to manipulate the container elements. The built-in arrays can be manipulated by standard library algorithms using pointers as iterators. Manipulating containers with iterators is convenient and provides tremendous expressive power when combined with standard library algorithms, in some cases reducing many lines of code to a single statement. Iterators encapsulate the mechanisms used to access container elements. This encapsulation enables many of the algorithms to be applied to various containers independently of the underlying container implementation. This also enables you to create new algorithms that can process the elements of multiple container types. Iterators have many similarities to pointers and are used to point to first-class container elements and for other purposes. They hold state information sensitive to the particular containers on which they operate. Thus, iterators are implemented for each type of container. Certain iterator operations are uniform access containers. For example, the dereferencing operator dereferences an iterator so that you can use the element to which it points to. The increment iterator or the plus plus operation on an iterator moves it to the container's next element, much as incrementing a pointer into a built-in array aims to a pointer at the next array element. First-class containers provide member functions begin and end. Function begin returns an iterator pointing to the first element of the container. Function end, on the other hand, returns an iterator pointing to the first element past the end of the container, so one past the end, a non-existent element that's frequently used to determine when the end of a container is reached. An object of a container's iterator type refers to a container element that can be modified. An object of a container's const iterator type refers to a container element that cannot be modified. iStream iterator and OStream iterator are we use the iStream iterator for input and the OStream iterator for output. And we use iterators with sequences called also called ranges, and these sequences can be in containers or they can be input sequences or output sequences. Let's look at this program in example. This program example demonstrates input from the standard input, a sequence of data for input into a program, using the an iStream iterator and output to the standard output, which is a sequence of data for output from a program using an all-stream iterator. The program inputs two integers from the user at the keyboard and displays the sum of the integers. If you look at line 12 creates an iStream iterator that is capable of extracting or inputting int values from the standard input object Cn. Line 14 dereferences iterator input int to read the first integer from Cn and assigns that integer to number 1. The dereferencing operator applied to input in gets the value from the stream associated with the input in. This is like similar to dereferencing a pointer. Line 15 positions iterator input int to the next value in the input stream. If you take a look now at line 16, it inputs the next integer from input int and assigns it to number 2. Line 19 creates an all-stream iterator that is capable of inserting or outputting int values in the standard output object cout. So compare line 19 to line 12. Line 12 is the iStream iterator. Line 19 creates the allStream iterator. Line 12 is extract or input the int value from the standard input object Cn. Line 19 is capable of outputting the int value in the standard output object cout. So cout, allStream iterator, Cn, iStream iterator. So line 15, if we take another look at line 15, it outputs an integer to cout by assigning to an output integer iterator as a I value in the assignment to the sum of number 1 of number 2. So line 15 outputs an integer to cout by assigning the output int to the sum of number 1 and number 2. That's line 22. Sorry. So line 22 outputs an integer to cout by assigning the output integer variable or pointer to number 1 and number 2. So notice how we use the dereferenced output iterator as an I value in the assignment statement. So if you want to output another value using output int, the iterator must be incremented with the plus plus first. So it has to be incremented first. Either the prefix or postfix increment can be used. We use the prefix form for performance reasons because it does not create a temporary object. So it's always better to use, you can use the prefix or the postfix increment, but it's recommended to use the prefix from performance point of view because it does not create a temporary object. File operations. Let's define a file. A file is a set of data stored on a computer and often on a disk drive. Programs can read from or write to files. It can be used in many applications such as word processing, databases, spreadsheets, and compilers. In order to use files, you are required to use the fstream header file. There are 3 types of data type that you have to use, or fstream header types that you have to use. Use the fstream data type for input files, the OFStream data type for output files, and you use the FStream data type for both input and output files. You can use the cout and cin or the cin and the cout operators to read from or write to a file. Also, you can use the EOF or end of file member function to test for end of input file. The FStream object can be used for either input or output. It must specify a mode and the open statement. Sample mode is the IOs in, the IOs out for input and output respectively. It can be combined, they're all in one open call, such as in this example, if you have df file.open, class.text, IOs in and IOs out. Files and streams. In C++, views each file as a sequence of bytes, as you can see on this image on slide 6. Each file ends either with an end of file marker or at a specific byte number recorded in an operating system maintained administrative data structure. When a file is opened, an object is created and a stream is associated with the object. In week 4, we said that objects cin, couts, cir, and clog are created when IOStream is included. The streams associated with these objects provide communication channels between a program and a particular file or device. File processing class templates. To perform file class processing in C++, the headers IOStream and FStream must be included. Again, the header FStream includes the definitions for the FStream class template, basic FStream for a file input, basic OFStream for file output, and basic FStream for file input and output. Each class template has a predefined template specializations that enables jar IO. Passing file streams objects to functions. This is very useful to pass file streams objects to functions. Just have to be sure to always pass the file stream objects by reference. Here we're gonna look at an example which demonstrates how file stream objects may be passed by reference to functions. And notice the function prototypes. We have two. We have the open file in, which takes an FStream as an argument and a string data type. Also, we have the show contents function or prototype function prototype. See, notice the cout statements being used here, and close property of the data file FStream. Just definition of function open file int. You can see it accepts an FStream object or a reference to an FStream object as an argument. So the file gets opened for input, and there's an if statement here that checks if the file fail, it returns false. If it succeeds, it returns true. And the show contents functions, you can see that it accepts as well an FStream reference as its arguments. Uses a loop to read each name in the file, so it loops through the file and then it prints out each line by line inside the file. So watch the output, how each line was printed, or